Alright guys, welcome to Review Test 6 Study Guide. I'm going to go ahead and go through and do the even problems here. So that's the only ones you guys have to do. Of course, I'm giving you the odds with the answers so you could get more practice and check your work if you want. Alright, let's begin. Question says use elimination to find the x-coordinate of the solution to the system. All right, a system of equations is when you have two equations and two variables, and your job is to find the value of x and y that works for both equations. There are two methods you can use to solve them, elimination and substitution. And as you can see, this problem is asking us to do the elimination method. So the first thing that you want to do with these types of problems is pick a variable to cancel. So I'm going to go ahead and pick the x. All right. The next thing we're going to do is we're going to flip and distribute the coefficient. Okay, so what do I mean by that? I'm going to put parentheses here. And I'm going to take this coefficient from the x, and I'm going to put it on the bottom. And I'm going to take the coefficient from this x, and I'm going to put it on the top. So flip, that means reverse them. So the 7's on the bottom, so I put it on the top. The 4's on the top, so I put it on the bottom. So I flip it. And now we're going to distribute these numbers into these equations. And that gives me negative 28x plus 49y equal 140 on the top. The second equation gives me this. Now those two steps, what they do for you, those first two steps, is they make sure that these come out to be exactly the same. But we don't want to be exactly the same, we want to be opposite. So the next thing we're going to do is we're going to multiply one of the equations by a negative. So I'm going to multiply one of the equations by a negative one. It doesn't really matter which one you do. I'm going to multiply the bottom one by a negative. So the top is going to stay exactly the same. It's not going to change. The bottom is going to have all opposite signs now. Okay. Step 4. Now that we've got these two numbers exactly the same but opposite signs, we're going to add, or I guess we should say combine downwards. So, for instance, if I add these together, I end up with 0. And they just cancel each other out. That was the point of all this. But since I add those, we also want to add these up. And those ones don't cancel out. For this one, we end up with 13y. And then adding these up, we are left with 104, it looks like. At that point, you should have only one variable left. And so when you have only one variable left, you should be able to solve. So just in this case, we would divide by 13. And we would end up with, I believe that would be 8. Okay. What you're going to do at that point is you're going to plug your answer in. To the original equation. Now it doesn't matter which original equation you go for. So I think I'll go ahead and do the bottom one here. But you're going to take that original equation and you're going to replace the y with the answer that we just got. We just found out that y equals 8. And at that point, you should be able to solve for the other variable. So now I'm going to find x. Division on both sides will give me x equals 9. And there's my two answers. You could write it as a point if you wanted to. The x value is 9, the y value is 8. There you go. All right, so that's the elimination method. If you want more practice with that, take a look at number 1, and you can try it. Move on to number 4 here. We have another system of equations. This time we want to use the substitution method. Okay? You want to use the substitution method anytime you have somewhere where it says y equals or x equals, which we do. We have a y equals right there. So we're going to use the substitution method to solve this system of equations. In this case, then, you have to start by finding where it says y equals or x equals. I like to circle what it equals. So here's my y equals, and here's what it equals. What you're going to do then is you're going to plug it into the other equation. So if y equals 3x plus 17, then I should be able to take 3x plus 17 and plug it in here for y in this other equation. And what that gives me is now. And that's why they call it the substitution method. At that point, you should be able to just solve the equation. I think that would be 119. And then let's go ahead and combine our like terms there. I think that's 96 if I'm not mistaken. Yeah, so I think that's going to go in there 4 times. So x, if you divide by negative 24, you end up with negative 4. All right. Then you're going to plug into original and solve. So we can find the other variable. So I've got x, right? So I'm going to come back into my original equation up here, and I'm going to plug the value I just got for x into that equation for x, and we end up with negative 12 plus 17, which is 5. So there's my y, there's my x, and we're good to go. That's the substitution method. So substitution method works really well when you have a y equals or an x equals. The elimination method is useful whenever you have all your variables lined up like that. So just as a heads up. Let's go ahead and take a look at number 6. They're going to ask us to evaluate, and they're going to give you a function. Oops, got it off too soon there. Here's my function. And they want us to find w of 1. And basically what that means is just plug 1 into your function. So w of 1 is equal to 2 times 2 to the 3 times 1 minus 1. So I just replaced the a with 1. And then from there, you need to know how to do your order of operations. So let's simplify that first. That's going to give me 2 to the 2nd power. Then we do exponents next. Then we do multiplication, which is 8, and then we'll add 1 last, which is 9. So final answer there will be 9. This one says perform the indicated operation. So they give us 2 functions, f and g, and then they want us to find out what this is. So we have 2 times the f function minus 3 times the g function. The f function, as you guys can see up here, is 4a minus 5. And the g function is a cubed plus 2a squared. And then we're just going to go ahead and simplify this expression by distributing and, when and if possible, combining like terms. But I don't think we're going to have any like terms here. Yeah, there's no like terms. Now they might write the answer like this, or they may put it in descending order where they have the biggest powered term in the front, followed by the next biggest powered term, and so on. I'm not sure, but it could go either way. Okay. Go ahead and take a look at number 9, we want 10. This is what we call a composite function. It's where you're plugging one function into another function. This problem is kind of unique because they only gave me one. And what you're doing is you're plugging that function into itself. A lot of times on these problems, they're going to give you two functions. Oh, that number 9 is like that too. That's interesting. Yes, maybe that's all they gave us. That's fine. We'll stick with this. All right. So how this works is you're going to start by writing the inside function first. So my inside function is the one that's inside the parentheses, that's g. So I'm going to write g of n is equal to n minus 3. Then we're going to write the outside function with empty parentheses. And what do I mean by that? My outside function, first of all, is this one on the outside. Now, in this case, it happens to be the same function. But like I said, sometimes they'll give you a whole other function. But in this case, we'll just write the same one again. But this time, instead of having an n there, we're just going to put parentheses where the n was. So that's what I mean by write the outside function with parentheses there. All right. The next thing we're going to do is we're going to drop the inside function down into the parentheses. So this is going to drop down into there, and this is going to drop down into there. And now I've got g of n on this side, which is what the problem's asking for, right? And on this side, we have n minus 3 minus 3. And sometimes you'll be able to simplify this side. In this case, it's not too hard. It's just n minus 6. So there's your final answer. All right, that's what we call a composite function. Let's go ahead and move on to number 12. This one's a lot like I think it was number 8, but this time they have a number here instead. So my advice is when you have a number actually plugged in there, what you want to do is find these things first. So let's start by finding f of 5. What that means is I'm going to take this f function here and plug 5 in for x. So I end up with 11 by doing that. Next, we're going to do g of 5. So I'm going to take my g function here and I'm going to plug 5 into it. So I get 25 plus 15, which is 40. So I've got f of 5 is 11 and g of 5 is 40. So now I'm going to come back to this expression right here, and I'm going to replace the f of 5 with what I got. F of 5 equals 11. And same thing with the g. I'm going to replace the g of 5 with what I got over here. G of 5 is 40. And from there, we should be able to just do multiplication and simplification, which I believe that one comes out to be 87. Okay. We'll take a look at number 14. This is another composite function like number 10. But this time, instead of having only x's, we've got a number in here. So my advice is find out what this is first. Find out what g of negative 3 is. So I'm going to take my g function, and I'm going to plug 3 in there, or negative 3, I mean. negative 8. So this part that I just boxed equals negative 8. And so what that means now is I'm going to plug negative 8 into my f function. So my final answer would be negative 11. Let's go ahead and move on to number 16. Solve each quadratic equation with a quadratic formula. So when you have a quadratic equation that is in this form, you can solve for x by using the quadratic formula. Right? You may notice that it's not in the appropriate format right now. So we need to get it in the appropriate format. And the way you're going to do that is by moving everything from one side to the other. So I'm going to minus the 12 in off of that side. And I'm also going to move the 12 off of that side so that there's nothing left over here and it's just equal to 0 now. But whatever you do one side, you do the other. So I also subtract 12 in and 12 from the left side. And that leaves me with the following, 10n squared minus 3n plus 2. All right? Now they're using n's instead of x's. So if it helps you, you can replace those with x's. But now we've got a quadratic equation in standard form. The one that is in front of the x squared is the a. The one that's in front of the x is the b. And the one that's without an x is the c. And do keep in mind that the b includes the sign in front of it, which is a negative 3. All right? So from there, we're ready to go ahead and start plugging things into our quadratic formula to solve for the x, or in this case, you could also say the n. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. The b value is negative 3. The a value is 10, and the c value is 2. That gives me 3 plus or minus 9 minus 80 over 20. Notice I did this piece, I did this piece, I did this piece, and I did this piece. The next piece we want to do is the square root, so I'm going to take care of this next. I'm going to do that work on the side, though, because it's, when I'm done, I'll put my answer right here. So, here we go. We have square root of 9 minus 80. Now, if I take 9 off of 80, I'm left with the square root of negative 71. Now, this is what we call an imaginary number. When you take the square root of a negative number, what we do is we take an I out, we get rid of the negative, and we put an I on the outside. The next thing you need to do is you need to break this down and take out your pairs. However, this is a prime number, so I'm not going to be able to break mine down, but I just want you guys to be aware that you do need to be able to break it down so you've got your pairs. And so now I've got this here. Sometimes what you could do at this point is you can reduce these three. You can only do it if all three of them are reducible, but in this case, they're not reducible, so I can't reduce. But maybe you'll be able to on yours. But that would be the end of this problem for me. Okay? So let's go ahead and move on to number 18. Now, this is also a quadratic equation. You'll notice something, though. I mean, if you want to think of this as an 81x squared instead of p, you can. But what's different about this one than the other one? Well, when you have this, then I say go ahead and do the quadratic formula, right? QF, quadratic formula. But if you only have this, if you don't have the b term with an x in there, notice that there's no just x's here. There's just x squareds. When you have that, I would say just solve for x, the old school way. Okay, what do I mean by solve for x in the old school way? I'll show you. Get the x by itself. So subtract 1 on both sides. Divide both sides by 81. 9 over 81 reduces to 1/9. Take a square root. Don't forget that when you take a square root, you do get a plus and a minus answer. Now, to take the square root of a fraction, you're going to take the square root of the top and the bottom separately. The square root of 1 is 1, and the square root of 9 is 3. So we have two answers, plus and minus 1/3. I personally think it's a lot easier than doing the quadratic formula. However, just so you know, you could do the quadratic formula with a problem like this. It's just that when you do it, you'd have to plug 0 in for the b value. And you should end up with the same answer either way. So it's your call. But let's go ahead and move on to number 20. This problem is telling me to graph this quadratic equation. Graph the quadratic equation. So to graph a quadratic equation in standard form, that means when it looks like this. This is standard form. What we're going to do first is we're going to find our vertex. Okay? The vertex is a point where the curves turns around, right? So, you need to find two different parts of your vertex. The first part is to find the x part, and we're going to use a little formula for that, negative b over 2a. So, here's my a, here's my b, here's my c. So, to find my vertex, we're going to do x equals negative b over 2a. Plugging in the numbers, I end up with negative 12 over negative 4, which is 3. So we've got our x. Now to find y, plug x into the original equation. Okay, so I'm going to take the original problem and I'm going to plug the x value that I just got into there. So I got 3, right? So I'm going to plug 3 in here. Make sure you do your order of operations appropriately. Exponents are first. Multiplication is next. And then just add and subtract from left to right. And you get negative 2. So I've got my vertex. It's the x value followed by the y value. The x was 3, the y value was 2. Okay. The next thing that we're going to do is we're going to determine whether we have a happy face or a sad face parabola. If your a value is a positive, that means you've got a happy face parabola. If you have a negative a value, that means you have a sad face parabola. Okay? So in this problem, my a value is negative. Okay? So that means I have a sad face parabola. At that point, we're pretty much ready to graph it. Okay? So here's my final answer. I'm going to put my vertex on there, 3, negative 2. And then we're going to draw a sad face parabola. And that's good enough. Okay? Final answer. Now, that was how to graph in standard form, but now we're going to learn how to graph or review how to graph in vertex form. Vertex form looks like this. This is another way that quadratics can appear. Now, when you have this, once again, we're going to start off by finding our vertex, but finding the vertex is a lot easier in vertex form. That's why they call it vertex form. This number here is going to be your x value, and this number here is going to be your y value for the vertex. What's important to understand is that this number will always be an opposite. So this h, if it says minus, then when you put it here, it'll be positive. But you don't do the opposite for the k. So if it's a positive k, you put a positive k. If it's a negative k, you put a negative. Okay. And then, guess what? The other step's the same also. If you have a positive a, it's a happy face, and if you have a negative a, it's a sad face, and that's pretty much going to be good enough to get a graph. So we should be ready to graph at that point. These ones are a lot easier just because the vertex is so much easier to find. You can find it just by looking at it. So for this particular problem, that's my h and that's my k, but we have to remember that for the h, we're going to change its sign. But we don't change the sign of the k, so I'm going to leave that as a positive 2. You'll notice that I've got a negative a value here, and therefore that means I've got a sad face parabola. And so I'm ready to graph. We're going to go left 2 and up 2, and then we're going to make our sad face, and that's good enough. All right, go ahead and move on to 24. Finding roots. All right, so when it comes to finding roots, what you want to do is break it down as much as you possibly can. So the first thing I'm going to do is I'm going to split the number 486 up from the p. Now the p to the 4th power, what that means is you just have p being multiplied by itself 4 times. Okay? 486, well, let's get to work. We've got to break this apart. I know 2 goes in there, so let's divide it by 2. 243. The 243, I think that can be divided by 3. 3 goes into 24, 8 and 3 once, so there's that. I'm going to bring the 2 down so I don't forget about it. And then I'm going to break this 81 up into 9 times 9. And then I'm going to bring these 2 things down so I don't forget about them. And then finally I can break each of these 9s up into 3s. And when you get down to the lowest number possible where they're all prime, then you're done. So I've got 2 times 3 times 3 times 3 times 3 times 3. There's that. And also p times p times p times p. So all I've done is I've broken this thing apart into its prime factors. So instead of 486, I'm going to write this. I think there were 5 of those there. And then, okay. Now, whatever this number is, that's how many groups we need to be present in order to take one out. So, for instance, I've got 4 3s here. That means I can cross that group off, and I can put a 3 outside of the root. Next, I've got another group of 4. Here's another one. So I can cross that group off and put a p outside of the root. These other 2 don't have enough to be able to make a group, so they stay inside. And you just multiply the pieces together now. So 2 times 3 is 6. And then 3 times p is just 3p. And there's our answer. So that's how you simplify radicals. All right. Let's go ahead and do this one here. There's a few ways we could do this one. I think the easiest way to do this, though, would be to multiply these first. 9 times 1/3 is 9/3. 9/3 is 3, and we're done. Take a look at number 28. Right. So these are equations that have fraction powers, and when we have those, basically the first thing you want to do is get rid of the numbers that are outside of the parentheses first. Now, after you get rid of all the numbers outside the parentheses, you want to get rid of that power. And the way that you're going to do that is by raising both sides to the reciprocal power. So instead of 5/6, I'm going to raise it to the 6/5. And whatever you do to one side, you need to do to the other. Okay, and the purpose of doing that is that when you multiply reciprocals, they become 1. And just for exponents, that means you don't really need to write it anymore. Now on this side, though, we have some interesting math to do. We want to remember that anytime you have a number to a fraction power, you can rewrite that where the b is the root, the a is the radicand, and the t is a power as usual. Okay, so in this case, I would rewrite this as the 5th root of 32, all raised to the 6th power. All right, so we want to find the 5th root of 32 first. So to do that, we're going to do it just like we did number 26. The first thing we're going to do is we're going to break this thing up as much as possible. 32 is 8 times 4. 8 is 4 times 2. 4 is 2 times 2. And so 32 is going to be written as 2 times 2 times 2 times 2 times 2. And I'm looking for groups of 5 numbers that are identical, which I just so happen to have here. So for every group of 5, you can circle it, cross it off, and put that number on the outside. You'll notice there's nothing left on the inside, and when that happens, that basically means you don't need it anymore. So the answer is just 2. So the 5th root of 32 is 2, but we still have that 6th power out there now. So now I've got 2 to the 6th power is equal to negative 16 minus 4n. Then you can do 2 to the 6th power. That means you multiply 2 by itself 6 times, which would give you 64. And from there, I think you guys would know how to solve this. So, what would that be? 0 and 1, so it would be 80. Negative 20. All right. So the trick here is basically get rid of the numbers outside of the parentheses first, raise both sides to the reciprocal power, and then use this property to simplify the root. From there, we should be able to solve. Right, let's hit up number 30. This is a square root equation. In a similar way to number 28, you want to get rid of the numbers outside of the root first. So I'm going to move this 6 over here. Now, to get rid of a square root, you can imagine that being like a 2 there. To cancel out a second root, you raise it to the 2nd power. Those are opposites of each other. But whatever you do to one side, you do to the other, so I have to square that side. And so now I've got 10p minus 1 equals 3 squared. And you guys know that 3 to the 2nd power is 9. So from there, we're able just to solve. So the trick there basically is how do you get rid of the square root? You raise it to a power that matches the root. There you go. And that'll do it. So hopefully that was helpful. Once again, you guys can just look at If you had trouble with one of these problems or you just feel like you want to practice a little more, just do the odd one right next to it, and should be able to get a little extra practice that way. But anyway, we'll see you guys in class, and have a good day.